Welcome all. In this lecture, we are going to study underdamped system. Since we derived the expression of C of S in the previous lectures as C of S equals to omega n square over S square plus 2 del omega n S plus omega n square, and we also know that when the value of del is less than 1, then the system is called underdamped system. So if the value of del is less than 1, then the system will behave like underdamped system. So to draw the time response, we have to first do the partial fraction of this expression. So omega n to the power 2 over s square plus 2 del omega n s plus omega n whole square is equals to a over s plus bs plus c over s square plus 2 del omega n s plus omega n square. So this is the partial fraction. On taking the LCM of this whole expression, we get omega n square equals to a multiplied with this whole term in the denominator, that is s square plus 2 del omega n s plus omega n square plus bs plus c multiplied with s. On putting the values and evaluating the expression, we get the value of a as 1 and the value of b equals to -1 and the value of c equals to minus 2 del omega n. So these are the value that we get after evaluating the above expression. Now substituting the value of a, b and c in the equation number 1. So putting the values of a, b and c, we get this whole term can be replaced with c of s, because c of s is equals to this term. That's why c of s is equals to a, here a value is 1, that's why 1 over s, plus here b value is -1, that's why minus s, plus here c value is -2 del omega n, that's why -2 del omega n divided by this whole denominator, that is s square plus 2 del omega n s plus omega n square. Now taking this minus sign as a common, we get c of s equals to 1 over s minus s plus 2 del omega n over s square plus 2 del omega n s plus omega n to the power 2. After this, we will make a whole square in the denominator by the help of this 2 term. So making whole square in denominator, we get C of S equals to 1 over S minus S plus 2 del omega n divided by S plus del omega n to the power 2 minus del square omega n square, and this whole term will be written as it is, that is plus omega n square. After this, moving to the next step, that is C of S equals to 1 over S minus S plus 2 del omega n over S plus del omega n whole square, and we take omega square as a common term, so plus omega n square 1 minus del square. Now we can write this term in the form of whole square also. That's why C of S is equals to 1 over S minus S plus 2 del omega n whole divided by S plus del omega n whole square plus omega n under the root 1 minus del square to the power 2. After this, we will separate out this numerator term, because this 2 del omega n can also be written as del omega n plus del omega n. That's why we will separate out this term. So writing this 2 del omega n as del omega n plus del omega n, we get C of S equals to 1 over S minus in bracket S plus del omega n over S plus del omega n to the power 2 plus omega n under the root 1 minus del square का whole square. And this is square bracket. Also, remaining del omega n term is there, S plus del omega n to the power 2 plus omega n under the root 1 minus del square, this whole square. Then C of S. After this, we will cross multiply the under the root 1 minus del square with both this numerator and denominator term. So 1 over S minus S plus del omega n over S plus del omega n whole square plus omega n under the root 1 minus del square whole square plus 1 minus del square 1 minus del square multiplied with this term only, that is del omega n S plus del omega n whole square plus omega n under the root 1 minus del square, and this is closing of square bracket. After this, we have to set up a form, that is C of S is equals to 1 over S minus square bracket S plus del omega n s plus del omega n whole square plus omega n under the root 1 minus del square whole square plus this del will move forward, so del, and this denominator will be written as it is 1 minus del square. After this omega n and this remaining under the root 1 minus del square whole term will be copied here as plus del omega n to the power 2 plus omega n under the root 1 minus del square to the power 2. We have done this whole thing because we have to set up the value of a as same in the numerator and in the denominator. Since we knew some Laplace inverse transform, that is inverse Laplace transform of 1 over s is equals to 1, and also inverse Laplace transform of s over s square plus a square is equals to cos of a t, and also inverse Laplace transform of a over s square plus a square is equals to sine of at. That's why we will use all these three formulas in doing the inverse Laplace transform. So taking inverse Laplace transform, we get here c of s will be converted into c of t equals to 1 over s will inverse Laplace transform of 1 over s is nothing but 1 minus whole bracket. This is the form of s over s square plus a square, and s is written with this term, that is del omega n. That's why we have to first do the inverse Laplace transform of s plus del omega n, that is e to the power minus del omega n t. After that this whole form is setting up like this. That's why s over s square plus a square, here a value is omega n under the root 1 minus del square. That's why its inverse Laplace transform will be cos of at, here a is omega n under the root 1 minus del square into t, plus this whole term will be written as it is del over under the root 1 minus del square, and after this we write this is the formula of a over s square plus a square, and here also the value of a is omega n under the root 1 minus del square, and this is also following the same expression. Since s is combined with s plus del omega n, that's why we have to write firstly e to the power minus del omega n t. After this inverse Laplace transform of this term will be sine of at, and here a value is omega n under the root 1 minus del square t, and closing bracket. So this is the complete expression, and if we take e to the power minus del omega n t over under the root 1 minus del square as a common term, then the c of t will become c of t 1 minus e to the power minus del omega n t over under the root 1 minus del square under the root 1 minus del square cos omega n under the root 1 minus del square t plus del sin omega n under the root 1 minus del square t. So we have evaluated the value of c of t, likewise this, and now let under the root 1 minus del square equals to sin theta, and since we know that sin square theta plus cos square theta is equals to 1, that's why here del will be equals to cos theta, and also we put omega n under the root 1 minus del square equals to omega d. Then putting all these value in this equation number 2, we get c of t like 1 minus e to the power minus del omega n t over under the root 1 minus del square sin omega d t plus theta, and here theta is equals to tan inverse under the root 1 minus del square over del. Since we all know that the value of sine ranges between -1 to 1, and we have here the sine term, and its value lies between -1 to 1 also. That's why from this expression of c of t, at if the value of sine term is equals to -1, so c of t will become c of t equals to 1 plus e to the power minus del omega n t, and if the value of this whole term will become 1, then at 1 c of t will become 1 minus e to the power minus del omega n t, and we also know that exponential has value either 0 or infinite. Exponential have value either 0 or infinite. Then if we replace t with 0, then c of 0 will become 2, and if we replace t with infinite, then c of infinite will become 1. Similarly, if we replace here c of t with c of 0, then it will become 0 only, and if we replace here t with infinite, then c of infinite will become e to the power minus infinite equals to 0. That's why c of infinite will become 1 only. Now plotting the time response curve. So this is C of t, this is t, this is 0, this is boundary of 1, this is 2. Plotting these two things firstly. So at C of 0, its value is equals to 2, so it will start from 2, and at infinite its value become 1, so its boundary will just like similar to this. And from this we get that at C of 0 its value will start from this point only, that is 0, and at C of infinite its value will tend to 1. That's why its boundary will also like this. So the curve of underdamped system will be somewhere between this boundary. So this is all about the time response characteristic of underdamped system. If you like my YouTube video, then please like my YouTube video and subscribe to my YouTube channel. Thank you.